Ever just stop and wonder how all of this actually works? You know, this invisible power that travels hundreds of miles just to light up your screen? Well, it turns out the answer is just incredible. And it all started with maybe the most unlikely scientist you could ever imagine.
You know exactly what I'm talking about. Those gray metal boxes you see on utility poles, the ones with that quiet, constant hum, they are the unsung heroes, the quiet, humming heart of our electrical world. They're called transformers, and they're basically the gatekeepers for all the power that fuels our civilization.
So what's the secret? How does this plain-looking metal box manage to wrangle one of the most powerful forces in nature? To figure that out, we've got to take a trip back in time. And we're not going to some fancy state-of-the-art lab. Nope. Get this. Our story starts in a dusty old bookshop in London with a young guy who taught himself science by reading the very books he was paid to bind.
All right, so first things first, why should you even care about this humming box? Well, because it is, and I mean this literally, the unseen engine that runs everything. Okay, so the job of a transformer is, well, it's right there in the name. It transforms electricity. Specifically, it changes the voltage. Now, you can think of voltage as kind of like electrical pressure. Power plants pump out electricity at this super high pressure, right? So it can travel for miles and miles without losing steam. But if you tried to plug your phone into that, poof, gone. So these transformers step down that pressure to a nice, safe level just for your outlets. They're the crucial middleman.
So who's the genius who cracked this code? This is where our hero enters the picture, a guy named Michael Faraday. And his story, wow, it is maybe the best example ever of how just being curious can literally change the world.
See, Faraday didn't have any of the stuff you'd expect from a scientific giant. He wasn't born rich, he barely had any schooling, he was the son of a blacksmith. At 14, he becomes a bookbinder's apprentice. But here's the thing, his workshop was his university. He just read. He read every science book he was binding, soaking it all up, because he just had to know how things worked.
And hey, don't just take my word for how important this guy was. Ernest Rutherford, you know, the physicist who discovered the atomic nucleus, no big deal. He called Faraday one of the greatest scientific discoverers of all time. That is some serious praise. So what was this massive discovery? Well, Faraday was completely obsessed with two of the biggest mysteries of his day, electricity and magnetism. Back then, everybody thought they were two totally separate things, two different forces. But Faraday, he just had this gut feeling. He thought, no way, these two have to be connected somehow. Fast forward to 1831. After years and years of tinkering in his lab, it finally happens. Faraday has his eureka moment, and it's a discovery that honestly becomes the bedrock of our entire modern world. What he discovered is something we now call electromagnetic induction. Now, here's the absolute game-changing part. It's not just that magnets and electricity are related. The secret ingredient is change. A changing magnetic field can actually make an electric current appear out of thin air in a wire next to it. That idea, it was completely revolutionary. And his experiment, it was so simple it's beautiful. He's got a magnet, he's got a coil of wire. That's it. If the magnet just sits there, nothing. Zilch. But the second he moves that magnet, zap, a little jolt of electricity pops up in the wire. Motion, magnetism, electricity, they were all part of the same dance. He'd found the connection. Okay, so moving magnets and wires. How do we get from that to our humming gray box? Well, it all boils down to a few key principles. Let's just call them the 3 rules of induction. This is the science that makes every single transformer tick. All right, rule number 1. A changing electric current makes its own voltage. So imagine you've got current flowing through a coil, and you start messing with it, making it stronger and weaker. The coil kind of pushes back. It generates its own voltage to fight that change. It's almost like the coil has a bit of inertia, you know? It just wants things to stay the same. Rule number 2 is pretty much the flip side of that. If you hook up a voltage to a coil, the current doesn't just show up instantly at full blast. Nope, it has to build up over time. The bucket analogy is perfect. The longer you apply that voltage, the more current you get, just like filling a bucket with a hose. And then there's rule number 3. And this is the secret sauce for transformers. The amount of voltage you can induce is tied directly to the number of loops or turns in your wire coil. You want more voltage? Add more turns. You want less voltage? Take some turns away. It's that simple. And that simple relationship, it's the key to the whole shebang. Okay, so we've got our 3 rules from Faraday. Now we can go back to that humming box on the street corner and finally see what's really going on inside.
So here's the play-by-play. An alternating current, or AC, flows into the first coil. Now, AC is always changing, right? So, thanks to rule number 1, that creates a constantly changing magnetic field. This field then travels through a chunk of iron to a second coil. And what happens then? Rule number 3 kicks in. The changing magnetic field creates a totally new voltage in that second coil. It's this incredible, invisible relay race of energy, all happening silently inside that metal box.
And how do we control whether the voltage goes up or down? It all goes back to rule number 3. It's all about the number of turns. If that second coil has fewer loops than the first one, the voltage drops. That's a step-down transformer, the kind outside your house. But if the second coil has more loops, the voltage skyrockets. That's a step-up transformer, what they use at the power plant. It's so simple and just so clever.
You know, it's really hard to wrap your head around just how huge this discovery was. Faraday didn't just stumble upon some neat physics trick. He basically gave us the keys to the kingdom, the blueprint for our entire modern world.
I mean, just look at this. The very same year he discovers induction, Faraday builds the first ever electric generator, the great-granddaddy of every power plant on Earth. 50 years later, in the 1880s, transformers make it possible to build massive power grids. And today, that same simple principle is literally everywhere. It's in electric motors, it's how your phone charges wirelessly. If it runs on electricity, Faraday's discovery is probably in there somewhere.
It's just wild to think about. The light over your head right now, the device you're watching this on, the entire internet, all of it, exists because a bookbinder's apprentice got curious and decided to see what would happen if he wiggled a magnet near a wire. It really makes you wonder, doesn't it? What other giant world-changing secrets are hiding out there in plain sight? Just waiting for the right person to come along. Not necessarily a genius in a lab, but just someone with that same kind of relentless curiosity to ask a simple question.